Welcome to the Triune Physics aka Physics Bible. Today we'll be solving problem under linear momentum in physics. A body x loses 2/5 of its velocity exactly when it makes a head-on collision with an identical body y at rest. Okay, after the collision, y moves off with a speed of 4 meters per second. Are you here? In the original direction of x. So the question is, what is the magnitude? What is the size of velocity of x before collision? The triune components, the masses x and y, identical, followed by their direction and their velocities. So we're going to use some shape to depict or interpret this question for better understanding. Is that clear? So let's do that quickly now. Let's insert objects of masses x and y. Solution. So let's insert this box. Let's insert another box. Let's insert another box. And the fourth one, yes, this depicts initial and final. So the arrows will depict the direction of travel, exactly, or velocity for the two. Okay, let's forge ahead. The first box is the first body x. Then we have body y, exactly. Let's do that for the final momentum. Okay, x, and we have y, exactly. Then we have u of x, which is unknown. Then we have u of y, which is 0 because it is stationary. Then we have v of x and v of y. Exactly. Then what can we show up here again? 4 meters per second is our v of y. And then v of x is given. Please take note of this. We have m of x, m of y, m of x, m of y. Okay? So we are good to go, isn't it? Alright, this depicts final momentum. Okay? And the upper one depicts initial momentum. Okay, yes. So can we proceed now? Let's interpret this properly now for better understanding, please. So m of x is equal to mass of x, m of y is equal to mass of y. Okay, and is equal to what? M of x and is equal to m. Why? Because x and y are identical. Exactly. Please take note of this. Let's proceed. So m of y is equal to m of x and is equal to m because they are both identical. All right. So u of x is equal to initial velocity of x and is unknown. U of y is equal to initial velocity of y, which is equal to what? 0, and is before collision. Exactly, since it's stationary. So v of x is equal to final velocity, okay, of x after collision. Exactly, is given. Then v of y is equal to final velocity of y after collision. Exactly. So, and it's given to be 4 meters per second. Exactly, from the equation it is there. So recall that x loses 2/5, 2/5 of its velocity, which is u of x. Exactly. Therefore, if we combine this, v of x will now equal u of x minus 2/5 u of x. Exactly. Please take note of this. It loses 2/5 of its original velocity. So simplifying now, we now have v of x is equal to, okay, is equal to The LCM for this, let's solve this. The LCM will become 5, isn't it? U of x divided by 1. So 5 into 1 is 5. 5 multiplied by u of x is 5u of x minus 2u of x, because 5 into 5 is 1. And 1 multiplied by 2 will give you 2u of x. This will give you 3u of x over 5. Is that clear? Please take note of this. We are going to use this for v of x. Is that clear? So let's proceed from the conservation of linear momentum. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So here we have mx ux plus my uy is equal to mx vx plus my vy. Is that clear? Yes, we're having positive sign because they both move towards the same direction after collision. Is that clear? Please take note of these. So since mx is equal to my and is equal to m, then if we substitute, we now have mux plus muy is equal to mvx, okay, plus mvy. Is that clear? So what is common here? We factorize, right? So that m into ux plus uy is equal to m into vx plus vy. Is that clear? So we can divide through by m. Is that clear? So let's divide through by m. M cancels out m. M cancels out m. Is that clear? So we'll be left with u of x plus u of y is equal to v of x plus v of y. Is that clear? Recall that y is stationary before collision. Is that clear? So u of y is equal to 0. Substituting, we now have u of x plus 0 is equal to v of x plus v of y. Okay? So that u of x will now equal u of x will equal v of x plus v of y. Is that clear? So can we proceed further? Yes, but take note of this. Take note of this. U of x will give you this. So let's proceed, but recall that v of x is equal to 3 over 5 u of x. Remember? So we'll substitute that into this now. So that u of x will equal 3 over 5 u of x by substitution. Is that clear? Plus v of y. So let's collect like terms. Okay? So u of x minus 3 over 5 u of x will equal v of y. Is that clear? So what's our LCM? 5. So now 5ux minus 3ux is equal to v of y. Is that clear? So cross multiply, we have 5vy is equal to 5ux minus 3ux. So that 5vy will equal 2u of x. Okay? So divide through by 2. Then we'll have u of x. Okay? U of x is equal to 5 over 2 multiplied by v of y. Recall that v of y is equal to 4. Are you here? So u of x is equal to 5 over 2 multiplied by 4. Okay? So that we now have u of x is equal to 20 over 2 and is equal to 10 meters per second. So take note of this. This is the solution to the problem. This is Neco Past question. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.